we are going through the proof of the classification theorem of compact surfaces. This is the theorem, and the first step of the proof is to show that every surface can be represented by its plane model. So a plane model is a polygon with labels on its edges that indicate how we need to glue the edges together in pairs. Right? So now step 2. Let me clarify step 2 by an example. So suppose that we have something like this. A, B, C, B, C. So notice that here, if we begin from this point, we're going to have A, then A inverse, then B, C, B inverse, C again. Now, so this A is supposed to be glued to this A, but this operation is easy to imagine and is even easier to perform in the real physical world. You know, you just need to. It looks like this. You have this, and then you just glue them together, and what actually happens is that these two edges disappear. So if we glue A to A, then they're just going to disappear, and the remaining part is going to look like this. So we are going to have B, C, this B, and this C. So in other words, what we can do, we can just cancel all pairs A and A inverse that sit next to each other. And so whenever we have A followed by A inverse, we just delete it. However, of course, we cannot delete it if there is nothing else. So if all that we have is A and A inverse, something like this, then there is nothing that we can do, because if we delete them, then there is nothing left. So if A inverse is all that there is, then our surface is just a sphere. So otherwise, after step 2, we can ensure that the result of step 2 is this, that our plane model doesn't have, well, anything that looks like x inverse. So a label followed by its inverse, well, or x inverse x.